The following movie will give you an overview of how to use the Inductive Distance Measurement or IDM toolkit. It is used to check the condition of rotating parts, for example on rotary kilns or ball mills during operation. Without needing direct contact, it measures the variation in the distance of the moving metal surfaces with high accuracy and high speed. Therefore, it can be considered as a contactless dial gauge. Out of the various possible applications, this movie shows how to measure run-out on girth gears. To use the tool, strictly follow the safety rules given by the respective plant and local authorities. The IDM toolkit comes in a strong and tight transport case, which mainly includes the following items: the IDM controller, different sensors with measuring ranges from 4 to 25 mm, 2 magnetic stands with extension rods, signal cables, and in the lid, the manual as well as the software for Windows, the TomTom-Tools Measurement Studio. To measure the axial and radial run-out, 2 inductive sensors have to be set up with access to the tooth tip and side face of the girth gear. In order to get the correct values, the sensor diameter should not be bigger than that of the tooth tip surface. Ensure that the magnetic stands and all of the pieces are firmly tightened. Plug the controller into the USB port of the laptop and start up the measurement studio. In the meantime, the axial sensor has already been installed. When the IDM controller is connected, it will be displayed in the software. Connect the sensors with the IDM controller. Preferably use input channel 1 for the radial sensor and channel 2 for the axial sensor. For safety, never place sensors where the teeth are engaging. Always install them on the outrunning side or far away from the pinion. Ensure that the sensor does not touch the measuring surface and that the distance remains with the measuring range. Note that when measuring on the gears, the surface area and thus the signals are interrupted. Therefore, the sampling rate has to be adjusted to 3 to 5 times of the gear mesh frequency. To start a new measurement, click on Measurement, New, IDM, Gear Run-Out. A channel setting window pops up. Name the channel. Choose the according input where the sensor is connected. And to have the right scaling, select the sensor. Now the graph and the value window are displayed. From the 2 available options, select the surface type which is applicable for the radial and the axial sensor. Click on the Start button or press F5 to start the first measurement. Immediately, the distance values between sensor and girth gear surface are being displayed. To calculate the run-out values and their position around the kiln, their software needs a rotation reference, typically the manhole. Each time the reference point passes by, push F9 to indicate the kiln rotation. A yellow line in the graph will show the position of the reference point. Ensure to push F9 when the manhole is in line with the sensor. After about 3 kiln revolutions, sufficient data has been collected and the measurement can be stopped. To stop the measurements, push the Stop button or F6. To better visualize the eccentricity and roundness of the gear, the radial run-out can be shown in a radar chart. In the line chart, it can be useful to hide some of the curves, so focus can be set on a specific signal. Do not forget to save the file. Then carefully remove the magnetic stands with the sensors and close the inspection door. Now all on-site activity is complete and the data analysis can be done back in the office. More information can be found in the manual or on the website of TomTom-Tools.com.